This is a tutorial on specific heat practice problems. An 800-gram metal black is heated by 50 degrees Celsius using 8,000 joules of energy. What is the specific heat of the black? This problem is asking us to figure out the minimum amount of energy required to raise the temperature of 1 gram of black by 1 degree Celsius. That's what the specific heat is. We're going to go ahead and first write out all the givens in our problem. Remember that we do that by first circling all the numbers given to us in an actual problem. So the first number I'm seeing is 800 grams. I'm going to circle the number along with the unit. Remember that the unit is your clue. It tells you what the number actually means. Then we know that we're heating something by 50 degrees Celsius, so that's another number. And then we're using 8,000 joules of energy, so I'm going to circle that as well. What I'm looking for is the specific heat, and as you remember from the notes, the specific heat is denoted as a capital C lowercase p. Okay, so let's write out all the givens. The unit of grams, lowercase g, tells us that it's a mass of that substance. So we're going to write down mass equals 800 grams. The next number that I circled is 50 degrees Celsius. And it's telling us that we actually raised the temperature by 50 degrees Celsius. So that tells us that there's a temperature difference of 50 degrees Celsius. As you remember from the notes, we use the delta T for that. It's not just the temperature, it's the change, the difference in temperature. The next number that I circled is 8,000 joules. Okay, so 8,000 joules, that's actually the amount of heat that we used. So that's our Q. And they're asking us to calculate the specific heat, which is the CP. Okay. Also, you remember from the notes, the CP is actually the amount of heat required for every 1 gram and every 1 Celsius. Now that we have this done, we can move on and write down the 2 for every statements. The first for every statement that we always write down is the specific heat for every statement. So it's going to go as for every joules of energy, there is 1 gram and 1 degree Celsius. Okay, so that's our first for every statement. Our second for every statement is the one that uses all the other numbers given to us in a problem that have nothing to do with specific heat. So that's going to be for every some kind of number with joules, there's some number with grams and some number with Celsius unit. So if you look into your givens portion of the problem, we know that we're using 8,000 joules, we're using 50 degrees Celsius, and the black has a mass of 800 grams. So now we have 2 for every statements. Now we're going to rewrite each one of the for every statements as our fractions. So the first fraction, there's an x. We have no idea what that amount of energy is needed for 1 gram and for every 1 Celsius. So that's actually what we're looking for. And the next for every statement is 8,000 joules, 800 grams, the bottom, and 50 degrees Celsius. Okay. Now it's just a math problem, simple algebra problem. Since you do have an equal sign between these 2 fractions, you can cross multiply. So I'm going to do x times 800 grams times 50 degrees Celsius. That will be equal to 8,000 joules. Should be 8,000. Missed a zero right there. I apologize. So it's 8,000 joules times 1 gram and times 1 Celsius. Okay. Since we need to have X all by itself over here, I'm going to divide both sides of the equation by 800 grams times 50 Celsius. I'll do the same thing on that side. And then I can go ahead and get rid of the units that repeat on the top and bottom. And that lets me know that my final answer will definitely have units of joules in it. And I'm going to go ahead and do 8,000 divided by 800. It's going to be 10 divided by 50, so that will give me 0.5 joules of energy. And this is my final answer. Well, actually not really, because the problem was asking us for the specific heat of the block. So the actual answer is 0.5 joules per 1 gram per 1 Celsius. And this is how you solve a specific heat problems.